Hi, so good evening, everyone. I'm Karishma from the TechContainer team. It's great having you all here. So thanks a lot for joining us today. So to give you a little bit of context about TechContainer, we've been using this platform to share knowledge on upcoming trends, and we've been hosting sessions on various emerging technologies every month, with this being our 17th meetup. So now moving on to the session plan for the day, to introduce us to reactive programming, I take immense pleasure in introducing the speaker, Ranjith Raj. Our speaker is a full stack developer involved in multi-tier application development using Java and related technologies. He is with Cisco Systems as a technical architect and has over 10 years of experience in software development. He's worked with object-oriented and functional programming paradigm, reactive and responsive UI. Recently, he's been working on microservices using Scala and front-end using Elm. So thanks a lot for being here, Ranjith. I'll let you take over now. Yeah.
Thanks a lot, Krishna.
Yeah.
Thank you. Okay, good afternoon, all. I'm going to present my slide. Okay, so first of all, thanks once again for joining this reactive programming. I'm Ranjith, as Karishma already introduced enough about me. So let's directly dive into what is reactive programming. Okay, I have very little bit agenda, but it has quite a number of slides to explain the what and why reactive programming, right? So we had enough learning about object-oriented, procedural, functional programming, and functional reactive programming, right? So now we're going to see what is reactive programming, and this will be giving you a different vision how to approach modern distributed architecture and the latest application, how they have been developed. And reactive on application level and reactive on system level, right? Those are two different names for the same concept of what reactive programming, how you can use and what can be best utilized out of this concept. And finally, we have a Q&A. Please feel free to ask your questions at the end of the session. If you really need answer some questions on the go, please ask it in the chat space. I'll try to catch up, or Karishma can stop me during the question. Okay, thanks a lot. A definition, right? I'm not seeing that properly. Yeah, so I'm just moving my window. Right. What is the so? Am I audible, right? So it's clear. Everything is fine, right? So we'll settle the base first.
Yeah, I think we can hear you okay, but I'm not actually able to see the screen that you're sharing. Maybe it's just me. If someone else can tell me, it will be great. Are you able to actually see the screen that he's sharing?
No, we cannot able to see the screen.
Yeah, we're seeing a white screen.
Yeah.
Okay, that's great. Let me try to reshare.
Sure.
I'm now sharing the entire screen. This should be fine now. What about now?
Yeah, we can see it.
Yeah, it's yeah, can see,
Thank
right?
you.
Yeah, okay. Thanks a lot. Yeah. Okay. Definition. Before talking about much of, from my perspective, we'll see what is the definition, right? Reactive programming is a declarative paradigm program, right? Paradigm concerned with data streams and the propagation of the change, right? That's that you can elaborate more than 5 page, I guess, right? So there are some new words if you are a newcomer, like declarative programming and the data stream and the propagation of the change, right? So these are all the three different terminology or the concept what you're going to see in the upcoming slides. So this is the source from Wikipedia. I'll be repeating the same once again. Reactive programming is a declarative paradigm. It's not the imperative paradigm, right? I used to clear that part first. And paradigm that concerned with the data stream, right? It's not the data, it's data stream. So it's something different. And the propagation of the change. We'll see what next. Okay. What it is? It was, we were seeing the slide about what is the definition, right? But what it actually, in simpler terms, program that reacting for event and change, right? So that's very important. What we normally do in the CRUD-based applications, you request some input or you post something that will be persisted in the database. If you wish, you will be fetching that information. It's all CRUD, right? All CRUD applications. But what if somebody changed the data that will be propagated to me? So that is what the first statement says, program that reacting for event or change. Consider this as an example. You have Facebook. Some of your one friend is posting something on his wall, right? It goes to his database table. Once it is stored, there is an event happened where all the subscriber or followers get notified for those change, right? You will be getting notified as you are a friend of him. You will be getting notification that says like your friend has posted something new, right? So how it happens? That architectural design paradigm, what we have to settle in our mind, that program that reacting for event or change. Okay. And next one is asynchronous model, right? You cannot be synchronous where your friend is posted, then your all your friends are getting late, right? Or when you post, then only your subscription will be coming on. So this cannot be synchronous model. It should be asynchronous model to make it more data live. And stop blocking thread. So thread, we always block the threads, right? If we are having a little bit background about threading, what we do is like we are starting the thread, right? What we do, we are not blocking the main thread. So that's what the intention of having thread, right? You have a main thread, it's running on, main thread is spawning number of threads, but you're not blocking the main thread, but you are blocking each thread. If you have a heavy IO bound operation, you are blocking each and every thread, right? That's what we are talking here. And attain concurrency with small number of threads. So now hardwares, memories, all cheap, right? We are getting cloud, all these things, but how far you can go, right? You have so when I started my career, I had core to duo processor. Now we have i7, we have Akka core, and we have a multi-core system, but we don't know how to utilize that, right? So this reactive programming is really going to help you, not at the core level, right? There will be an API, what you're going to use, right? You don't worry about how this is managed at the background. So attain concurrency with small number of threads. So you're going to use your hardware more efficient than ever, and utilize resource at maximum. That describes the above sentence very well. And order of the instruction does not make your program anymore. If you are thinking in a synchronous model, you'll be following your code. When you are reading, there is an order, right? First you are validating, you're updating the database, you're calling the third-party system, and you're updating it again in the database, then you are sending to the user. Those sequence of order is no more useful, because you are going to make your code asynchronous. Maybe some of you have worked on JavaScript very well, so you may know what is the asynchronous way of calling other third-party systems or the other APIs, right? Okay, so that's it. What is reactive programming, and some of the example of reactive programming in real world is like stock market applications. So stock market application, whenever there is update happened at the back end, right? So that will be propagated to you very instantly, because you cannot be that the data cannot be delayed. That will make a lot of issues on the financial sector, right? And feed processing, yeah, you have a Twitter, Facebook, LinkedIn, right? Any other social media, you always seeing the feed processing, right? Have you ever tried to scroll through all your Facebook feeds, right? I think it's like Akshay Patra, right? It will keep on flowing, right? How much data they are processing in a day. So that feed processing is stream, right? Stream processing. And real-time editor, if you are working with some online editor, like we have a Google Doc. Whenever I edit in my laptop, some of my friends also editing the same line, so that will be notified. I can see literally that whenever he is typing some text, I able to see the changes in my browser, right? So that and all making the internet more useful nowadays, that we are not feeling that we are in a remote place. We are seeing that my friend is sitting behind me, like in office, right? That's cool. All these things are bringing the latest trend. I'll move on to next slide. Okay, why I want to learn reactive programming, right? So the classic classic three-tier architecture does not fit now for the recent style of internet usage. The one example is like nowadays we are talking about IoT, right? So all our devices are connected to internet. Nowadays I can see more wearable and even washing machine and your AC, fridge, everything connected to internet, right? Alexa, right? Alexa is one of the good example that it's connected to internet. It sends all your data, right? Whenever you speak something, it goes and search results, and it output gives output. Even your mobile phone, right? It is kind of internet of things, right? Or we used to say in Cisco, like it's the internet of everything. So these and all sending information and capturing, getting information very frequently, not like a human, right? You are typing something and you are waiting for the result, but systems are not like that. IoT systems are not like that. So it need more data to process. So how you going to deliver those data more faster than the existing or the classic tier architecture? And advancement in the hardware and microservice architecture really need these new style of programming to, because we have broken all our monolithic application into multiple microservice, right? So each and every components are interacting over the internet. It's not like one monolithic application interacting within Java API or other framework API, right? It is interacting through the internet. How to make or how to reduce the bandwidth, so the traffic, how to use the internet more efficient. All these things are matters that brings the reactive programming. And the live data flow, as I said, like we have more data flowing. We are living in the era of data flow. Okay, so this shows this shows why again, why again. So there are monolithic, we went to SO architecture. I just grouped those two in a same sector, where you can see response time was discussed in seconds, right? But now in microservice we are talking in milliseconds, and the data volumes was in GBs. Now it's terabytes, and petabyte goes, right? It goes to petabytes. And scalability and availability, it's very low, right? So the SOA architecture, it's not easy to scale. You can see that it's a monolithic application, how easy to scale your monolithic application into another instance, right? So there was availability concern with multiple nodes, but scalability concern was little ignored, right? But though some of the companies or some of the great engineers architected in a different way the same scalability, but in general I'm talking in the how all majority of people were using this monolithic in the scalability perspective. But now microservice, it's too high, right? Whenever you are getting more loads, you are spinning your instance to respond your customers immediately. So high availability, high scalability is possible with microservice and the cloud computing era, right? Okay, moving on to next slide, right? This is what the real properties of reactive programming. You just please focus on here. It's very few points, but it has more understanding you're going to acquire. So responsive, resilient, elastic, and event-driven. What is meaning of responsive, right? We used to say like a responsive UI, responsive design in the UI terminology, and the resilient, elastic, and event-driven are we going to see what all those. So a little short story about me. I was in NCC. I was a NCC cadet in the college. Right. I learned many things during those phase, and I would be interested to incorporate what I learned in my NCC and what I'm learning in the reactive programming. Right. It would give you a real-time example how we are really being as a reactive right to the others. So humans are more reactive, right? If I ask someone, hey, could you please tell me your name, right? So he'll be responding to me. So that's what the reactive. I'm touching him or I'm calling him, he's going to respond to me. Hey, so that's again a responsive. How it going to be happen? Okay, so responsive. When my cadet or my we used to call as a petty officer or the captain, right? When my captain called me, hey Ranjith, right? Then I immediately want to respond him, right? That's the responsiveness what I have. I cannot say like, hey captain, wait for 5 minutes. I have called with my girlfriend, right? I cannot say. So I have to be responsive to my captain, as like our application should be more responsive to our customers to make our business in a next level. So responsiveness could be explained with this. I'll be moving to resilient, right? What is resilient, right? I used to go for parade during that NCC life. Like when I'm in the parade or march past, if I make any one mistake or any cadet, if they are making a mistake, right, that will be clearly visible outside because everyone will be in the sync to the drum beat. If I make a mistake, I have to tap my foot 2 times so that I will be in sync with others, right? So this is a small trick what we used to play in the march past. It is similar thing like you cannot be uh, in a failed state for a long period of time in your application, right? So your application should come back as much as possible, right? So as quick as possible to serve to customers. If one system went down, we have to boot other system, right? So that is kind of a resiliency that explained by how it was there in my cadet life, right? So resilient means fault tolerant. So you come back as immediate as possible. Okay, elastic. I can name it's a fancy word. Elastic is a fancy word. I can say it's like a scalable, right? How easy to scale your application. You are getting you're getting more requests, right? Are you going to respond? Are you going to time out your customers, right? Okay. So again, the same cadet life when I was in camp, right? When my captain said dismiss, everyone will go very happy. We take our own responsibilities to fold the mat and untie the knot and we together take all the vessels and properties, right? So there is no responsibility defined by captain like you go and do this one and you go do this one, right? Wherever we get an opportunity, we go and do that one. That is the elastic thing, right? So we have a resource how to serve in a better way. That's elastic. And how to achieve all these things? Elastic, resilient, responsive, it's by the event-driven. Event-driven is not new, right? Event-driven is there from even 3-tier architecture or Java EE also. Like we used to have our Java MQ, right? JMS, where you put some information there, and based on that event, somebody will observe your messages. They'll be reacting to it, right? So that is what the event-driven architecture it is. So event-driven architecture can be explained in this image that how human is communicating, right? There is one guy at behind me, he'll be giving me command like go, 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 right? In that case, when he's giving command, he's giving me message. I keep listening to those messages, right? I react based on that message. If I get thousands of messages, I'll not able to complete in a shot, right? I'll be processing each and everything one by one. If there is other guy who can help me, I can share those messages with them. So that is what the scalability perspective. Okay, I believe that explained the manifesto of reactive programming. So these four are the manifesto of reactive programming. I already overconsumed 25 minutes. I'll be quickly going through all other slides. Please come with me. If you have any questions, we can discuss at the end. Okay. So event-driven. Event-driven is the base for elastic and resilient. Responsiveness. As your application is more responsive, so that it is being constructed in the manner of resilient, and it is elastic also. So you are achieving responsiveness. So this picture would give you more idea how these four properties are connecting. Okay. Give me a minute. Okay, so imperative versus declarative. What is imperative, right? So what we do in a C++ or okay, object-oriented programming, you can take it as a Java, right? So Java, we are writing imperative programming earlier. Now after Java 8, we are writing functional programming also. Don't think that Java is completely imperative or completely object-oriented or completely functional, right? So language is something different. The programming style is something different, right? So language implements those programming style to serve you better. So imperative is a style of programming that says how to do. If you have a method, it says you have to instruct that how to do. Rather, in a declarative, you are instructing at what to do. You'll have a example of what is procedural and object oriented. Those are you are instructing line by line how to do, right? But in declarative, you are instructing what to do. You are doing math and do result, right? This is something what to do, not how to do. So declarative programming gives us a functional programming and reactive programming. Let's see what is reactive programming next. Once again, right? So imperative versus reactive style, right? This is not imperative versus declarative style. We are digging into reactive more. So if you are writing this expression in your programming language, object oriented or imperative style, right? So C equal to A plus B. In some case, I'm giving A equal to 10, B equal to 10, right? In that case, my result will be C equal to 20. But what is reactive? It is if I change the value of B after the execution of C, right? Which means this expression is evaluated and the result is stored in the C. A plus B is stored in C. If I change the value of B, the C will not be reflect, right? The C will not be reflecting that. So that reason is like because that's an imperative style. It's a line by line execution. Now coming to the reactive world, where if you change the value of B, automatically the value of C will be changed. Don't think that you are writing a program line by line. After executing the third line, if you are changing the value of fourth line, that will be again changing the value of this previous line, right? It's something logical you have to think. I'll give an example. So the better reactive application is Excel sheet, right? If you are writing C equal to A plus B, consider C is a cell, A is a cell, B is a cell, right? Whenever you are changing a value of A, the C will be recomputed, right? The value will be re-evaluated. That is what you have to understand the reactive programming it is, right? I'm not telling about the language or how to code. I'm telling how you can think of programming in a fashion, right? The fashion of writing reactive programming you can understand from the Excel perspective. Okay. Yeah. Now we are entering into what is stream. So stream is a sequence of ongoing events ordered in time. Consider, as I said, your friend is posting messages or posting what do you say? Posting something on his wall, right? So Facebook post. Each and every Facebook post is an event. This is streaming. You are subscribed to that stream. If your friend of friend is also following the same guy, in that case you will be he also following the same stream, right? So consider stream is a pipe, right? There is a pipe where all your data are flowing. The next slide will explain more detail. Consider this one. There is a publisher, there is a subscriber. Though there is a mistake, ignore that. It's a subscriber, it's not subscriber. So subscriber, publisher is publishing some events, continuous event. Think like I'm speaking, right? I'm speaking. This is continuous event. There is a relay. So this is streaming, so that you are subscribed all over, whoever there in this meeting or this event, you are subscribed to that stream. You are listening whatever I'm speaking, right? That is what the subscriber and publisher. Let's see this diagram, right? So there is a radio station. Yeah, I think everyone fan of Radio Michi, right? So if there is streaming or the song or the talk is going on, all whoever's joined here, right, could be hearing or listening to the FM, right? It doesn't mean that if I stop listening that the stream is closed, right? It means my receiving end is disconnected. So you see here, there is a receiver 1 and 2. Both are going to receive something. If there is a disconnection, the stream still is relaying the content to the other consumer. Right. So one advantage is like the stream can be closed. Like our FM Rainbow or something, right? They'll be, I'm not sure whether they are disconnecting their service by midnight, but still, right? So there is a way where your stream can be disconnected from the producer, right? When they are running out of data, they'll be stopping that, right? Yes. So that's what the stream, you can consider the publisher is equivalent to observable. In a different language, we used to have a different terminology. So observer or publisher are same, subscriber is same for across all different implementation. Okay, why I need a stream? Because you can apply function on a stream, right? So how I'm going to apply function on a stream? So I have a receiver in my home where I'm applying a function called bass, right? I'm increasing bass. I'm increasing volume. The same content, the same data is more volume in my home because of my receiver. I'm applying some function on it. Similarly, you can apply some function on the stream. So you can consider that, ignore this buffer now. Let's make this one first. Map, right? You can map the stream into this stream. And you can filter as like a Java stream, right? So you can do all these things for the live stream. Okay, what is this buffer? I'll be explaining the buffer and some other slide. We can see that one. Okay, some of other methods: stream operations, map, flat map, filter, reduce, zip, merge, concat, interval, or some of the methods we have in the stream operation. There are a lot of other operations you make use of it. Okay, applications of reactive function. You see here, reactive programming, how you can write an application. Consider this an application of text search. Okay, so Google, right? If you're typing H, it will give you list like hello world or hippopotamus or something, right? H starts, and if you say he, right, you will get something, he, man, or anything, right? And if you make HEL, you will get other result. That's how we have to think about the stream. So input is what you type. You are typing HEL, right? HEEL, all these things you are typing. You can type even wrong, but computer or that is accepting all your input. But who is mapping those input into a valid text? That map there in the backend. So the stream is your input. You are typing keyboard text, right? You're typing text in your keyboard. All these things event. Each and every key, entered key, is a event here, right? HEL is an event. Those event are mapped here, right? Consider that each and every text what you're typing is mapped into a code. So H with code, HE with code, or E with code, L with code, all these things are fired to a query, fired as a query to the database. I did not have a link because that will make this image clumsy. So that I just reduced the link. Hope you all get how the query will be triggered to the database, right? So it's a simple text search, how your keys are mapped to a query in a live stream. Okay, let's move on to next application. We have a stock code stream. There is a stock stream running. You are subscribed to it, but you cannot subscribe for every event, right? If the stocks are updating in a second, right? How you going to handle those? Or even go back to this one. Your user is typing text, right, very fast. Are you going to fire each queries for each text, each character? No, right? You have some mechanism to conclude that he typed. So now we are going to go and find the result. That's what the buffer it is. You can, so the curly braces here is telling that there is a throttle. You can set a throttle, how much event can be combined, or the time. So within this period, there are two events happen that is made as a one list. So you are combined, you have combined those two in a list. So that will be sent to other stream that will be going to query. So the next one is like, here is only one, the next one is having three. So this is something called buffer, where buffer is also another function where you can apply on the stream like a map. So that will be very easy. For last 5 minutes, you are getting all the stocks updates in a one shot, right? You are subscribing to the stream. Yeah, you can make average out of those lists, and you can take a mean to make some data model. All these things can be possible with this function. Okay, there will be a question, right? Is it possible only I can make all these things with reactive programming? Not at all. Not at all. You can write your own concurrent code to make all these things possible. But Java 8 had a function, introduced functions, functional programming, right, where you have map all these things with a stream. But after Java 9, right? So Java 9 onwards, you have got Flow framework, right? Flow API. Those Flow API is a reactive way of handling the data. So Flow is a good way to handle the data. I'll be covering in the next slide. So for now, we'll first quickly go through what is Future, CompletableFuture, and Java Reactive Stream. So this Java Reactive Stream is what the Flow API available in Java 9. Right. Okay. So Future is a placeholder to get a response from callable. So we normally used to submit the thread, right? But if ever we want to get a result, we need a future, right? What is the future? It's just a placeholder. Once the result is computed, that will be placed in the future where you can get the data after some time. Once the data is ready, you can get it. So I have an example, like you have a list of cones, right? So you are in an ice cream parlor where you want to make you are getting an order and you want to produce the result. So there is an executor service. Executor service is a way to handle the threads in a pooled connection. I have a new fixed thread pool. There is a cached pool also, but new fixed thread pool I'm initialized with 5, where you are submitting many orders. So clearly here we mentioned only 3 orders, right? One is blue cone, red cone, and gray cone. So these 3 orders I'm submitting it. Consider that the ice cream parlor guy is going to decorate all these things and taking thread sleep of 2000 milliseconds, and he's returning, right? This absolutely blocking. If I gave 1 cone to this one, I have been blocked for 2000 milliseconds, right? After that, the red cone goes again, the gray cone goes, right? But consider if I have a resource at the back end to make order easily, so I can scale it, but still my future is blocked. I cannot do anything, right? That's you can avoid by using completable future. The future that may be explicitly completed, setting its value and status on non-blocking fashion. So you will not wait like a future. The completable future will submit all the data, but it will wait to collect the data result. So here the same. You consider here like a completable future supply async. Still you can do synchronous also, but the async is what we need here. So then apply, then apply, then apply. I'm doing some additional task, as I described in a previous slide, that there is some decorative functionality going to happen at the backend ice cream parlor. I just described what it is. You see here, I'm taking the cone 1, blue cone, and I'm picking the cone 1, right? It picks the cone 1, and it adds some flavor, it decorates it, it wraps it, and it delivers it. These all things are going to do in an asynchronous manner. It does not mean that the blue cone will wait till the red cone will wait till the blue cone is delivered. So that's the completable future, what you can think of, and you can you can complete your future at any time. Reactive extensions. I think I have 15 more minutes. I'll just quickly go through it. Reactive extensions is what the ReactiveX it is. We have Rx Java, Rx JS, Rx5, and Ruby also there. And there are a lot other frameworks also support, so languages also supported by this reactive extension. Project Reactor is another one where the Spring is implementing. It's called Flux, right? And the Akka stream is a classic one. You can really use that one. The Akka has Akka cluster, right, where you can submit all these kinds of order. The cone submission, backend processing order to the Akka cluster, where you can scale the Akka cluster. You can get the result easily. And Java 9, the Flow API, what I was discussing, and there is a Vertex IO, which is also one of the reactive library or framework. Why it is mentioned as an extension, right? It is not a new programming language. You use your own language. It's a Java or JS, right? But the reactive extension is giving you extension to write reactive style of code in your language. Okay, Flow API, the highlight of what Flow API has: a publisher, subscriber, subscription, and processor. What is a publisher? Hope everyone knows, right? Whoever publishing it. Who is subscriber? Whoever receiving it. Subscription. Once I started subscribe, right, I get session between publisher and subscriber. That is called subscription. With that subscription, I can do next. And processor. Processing is a stage, right? I have a 2 publisher. What I can do is like the publisher 1 emits something, I can go and attach a processor where processor is a receiver to a publisher 1, and he can be a publisher to a receiver 2, right? So you can couple, you think of it as a pipe operation, right? So processor is a pipe where you have a flow of water in your home, where you want to, from the tank, you want to take it to your sink, right? It's not directly going. You have some process, right? You are filtering, you are giving pressure to the water. All these things are kind of a processor. Okay, it's again same how the flow is happening. As I'm running out of time, I have 15 more minutes. I'll just quickly go through this. So subscriber calls subscribe method, and I get on subscribe, and I go next request. I'm requesting the subscriber publisher to give me data till the complete, right? I got the subscription. I'm asking, give me first data, give me second data, give me third data, right? Each and every time when I ask on next, he will be giving data. When he's running out of data, he said, I'm done, on complete, I'm done. Or he can say, it's an error. He cannot give me any more data. So consider the difference between stream and reactive stream is how reactive stream is handling error. Error is also one of the data. In stream, Java 8 stream, handling exception is very difficult. But in reactive stream, there are three different channels. One is data channel, one is complete channel, and another one is error channel. You are subscribing and you will be receiving those information from the specific channels. Once you receive on error channel, you will not receive on complete, right? So that's all, your stream is closed. Okay, so ReactiveX, how ReactiveX is working, this is flowable, right? If you have experience on ReactiveX, ReactiveX 1, RX Java 1 has observable, but observable did not have a back pressure handling. But the flowable is Java 8, sorry, Java 9, right? The flowable API. So Java ReactiveX, which means a Java RX Java version of reactive stream, right? RX Java started supporting Java Flow API. It's an implementation, right? It's an implementation for Flow API. So you can see like flowable from iterable. Iterable means it's a list. So you can have a from array, from iterable, from list. Many things are there. So you mapping and you are subscribing. Here is the key. When you are subscribing, you are passing three functions. The function 1 gets data, function 2 gets error, function gets unit, right? Unit, that means no, nothing. Then it is done. Right? So this is what I said. It's three different channels. Okay, so what it is add wrapper? I just want to tell you, like, my reactive app add wrapper is a static method available inside the my reactive app. So that I passed once I screen each and every element from this list is passed. It will check whether the data is there or not. I'm voluntarily throwing when there is a gray cone. I'm running out of gray cone now, so I'm throwing illegal argument exception, no stop. How it going to handle? It going to handle with the E, which means error. Fine. Yeah, it talks about Akka. I'm skipping Akka now. So you just see instead of flowable, it has source. If it is Java flowable, it is publisher. Something different, but you can see the same model from publisher in all this day. So the only thing is like an actor materializer. As I said, it's an actor model of handling this reactive. You can have your cluster also mentioned. So this describes what is different between stream versus reactive stream. I'll be sharing the slide so you can go through it, or it is available from the Git. I'll be skipping this now, as I discussed already that it handles back pressure. Reactive handles back pressure, and the data and the pull and push mechanism is there. but the stream is just a pull mechanism. And you can have a sequential or parallel with the stream, Java 8 stream, but here it's asynchronous or non-blocking with the back pressure. So asynchronous is the advantage of reactive stream, and error handling is better here, but in Java 8 stream it's not easy. So back pressure means I really want to discuss this here. What do you mean by back pressure, right? When there is no subscriber, why do you want to publish? Or when the publisher is not able to receive, or he's saying like, I'm not able to consume all these things, right? Consider this as an example. If I'm talking 2x speed in this session, right? What my subscriber will be doing, right? Whoever there as attendees, you'll be saying like, Ranjith, please can you stop and go a little slower, right? That's what the back pressure is. If you're not asking any question, what I see is like, okay, there are no subscriber, nobody is listening to me, so I'll stop my speech, right? That's what the publisher it is. This is called back pressure. So this back pressure is a real advantage in reactive programming. So you are not wasting your resource. You are controlling it with back pressure. So I have a demo. Yeah, I think I have quite enough time. 10 more minutes is there. So I have a simple example for how to use this reactive. I'm going to use a Twitter live stream. So NLP, I'm going to, whoever don't know the NLP, I just give you a high level, right? Natural language processing is what NLP it is, right? However, we speak, the computer is trying to analyze your data and trying to interpret it to a valid information. So in a NLP, there is a sub group or sub department which is called sentiment analysis, right? If somebody is commenting on the post with some good positive things, right? How we are going to identify whether he's happy or not. So that with the sentiment analysis, even it goes to bad also. Yeah. So this is something is used in the review of product, target advertising, and political campaigning, right? These are all some of the usage of sentiment analysis. I'm going to use that in my demo. I'll be showing that next. So this is the screenshot of my application. What it shows, like you see, I use the word called Trump, right? As the election is going on, election is coming next, US election. I just try to find how much positive that Trump gets the tweet. So Trump is the everywhere there in the text, right? So I'm following the I'm subscribing to the Twitter stream, and I'm applying function, the sentiment analysis function on it, and I'm showing that positive here, negative, neutral, negative, neutral, right? So this is one example that how live streams are used. Even right, the Spark is having a live stream. How you can apply to this. If you know what is Kafka, right? Kafka also handles live streams, real-time data. You can subscribe to Kafka stream and you can apply all these things. But to make demo cool, I just made Twitter, and this is the next example, like who to follow. If you used Twitter, you have a recommendation. Whenever you close this first one, you immediately get other data filled in, right? How it is happening? That's reactive programming, because there is a persistent connection in between your subscriber and the publisher. Whenever the publisher is asking, give me next, then the data is already prepared at the back end. So it's just pushed it. He knows that, give me on next. I show you an example, right? Once you subscribe, you are asking, give me next, next. Once you're done, complete. That is what this example it is. I'll be showing this as first, then I'll go to the Twitter live stream. Okay, so this who to follow, I'm just refreshing it. I'm getting data, right? I'm planning to close this one. Are you seeing my screen? Okay, I hope yes.
Yeah.
So I'm closing. Yeah, thanks. So I'm closing this one. The data is filled immediately. I've closed this one. The data is filled, right? How it acts. The action is written in a reactive fashion that there are subscriber. You see here, right? So if you see here, I have some subscriber. I have a close button 1 and 2 and 3. I have created Rx observable. I'm observing for the close event. Whenever the close event happened, I'm fetching for a new data. Fortunately, I'm not triggering to. I'm not fetching every time to the other system. But it's not live. I'm fetching. I'm holding the data with me, and every time I'm taking the data from my local. So this is a classical example that there is a persistent connection. Closing is triggering on next event. That on next event is giving me new data to fill in this location. Right? Okay. I'm not going through the code because code is there everywhere, right? I want to give you a high-level idea about how to use, where to use, how it is applicable in my project, and how this is written. If you're seeing some application, you just think about how this could be written. Okay, so this code is also available in the GitHub. I'll be sharing the code and slides later. I'll be just showing you how to start my server, right? This is Spring Boot based application. I'm starting my server with Java-jar, right? So Spring Boot start my its own container. You see that, okay, it starts I'm starting my application. My Spring Boot application is started, and it's a Spring Flex basically, right? So Spring 2.x onwards, there is a reactive support. Spring 2.2.2 is what I'm using. I think 2.2.3, I guess, right? So I'll show what version I'm using. Yeah, it's 2.3.2 is what I'm using. What it do is like it started watching the live stream. You see here, I'm getting some tweet, and once this tweet is received, what it do is like it try to push into my MongoDB. Because MongoDB we have a reactive driver. That's so you can use rather than using MongoDB, you can use Kafka also. So I'm going to start my reactive applications or React.js application, right? So you have to think like really that this is only for a demo, right? It cannot go to a production, and Reactive and React.js are totally different. The name something similar like Java and JavaScript, right? Okay, yeah, so you see the live stream is flowing. If you guys or wish to tweet with the keyword called reactive, yes, you can be listed here. Right, so you see React, it says neutral. Yeah, obviously reactive, it's all neutral, right? Nobody knows better, or nobody sees it's a worst scenario, right? So it's all neutral. So I don't want to show this for a demo. That's the reason I was showing you with Trump one, right? So you can see how sentiment analysis are done on the Twitter data. Yeah, it's still the data is flowing. I'll show how this is working, the code walkthrough as well as the architecture. So this is for the live stream demo app it is. The Twitter is exposed a stream, and receiver is following it. Receiver is a subscriber from the webflux. That receiver is pushing data to MongoDB. This is again exposed to webflux, and those data event or change, each and every change happened on the MongoDB will be exposed via this webflux reactive framework to reactive event stream. And the JavaScript event source, JavaScript has something called event source. That event source is receiving or subscribing to my REST live stream and displaying it in the reactive application. So I did not change this logo. The reason is I want to show that it's a reactive. I'll be showing the code base now. Okay. How many? Yeah, one more minute. Yeah, let me show the code here. I have runner application. The run, what it does, like the command line runner. Once my Java -jar, my application started, there will be a command line runner which start listening to Twitter Stream Factory. I'm passing Twitter configuration because you need to give your own authentication, right? The keys, all these things. And this is passed, and I'm getting status. You see, once I started subscribing on status, it is getting a status, right? Which means a tweet. I'm converting that status into my tweet. So this tweet is my tweet. Ran reactive. I'm converting that using the from status. Then what? I'm going to persist that into database. So I'm doing tweet repo, save all the tweets. So here it's not completed, right? It is not kind of an array list. It is a stream. Whenever the data is pushed, immediately it will be pushed to save all. So that's the classic one, right? So you see, I'm not doing anything. Just the Flux is giving me, there is a tweet repo. I'll show you what tweet repo is. So tweet repo is a reactive CRUD repository. If you ever used Spring Data exposed, given a lot of other things like a JPA repository, CRUD repository. Similarly, after Spring 2.0 released, it's a reactive CRUD repository. So whenever the database got new event or data, it will be pushed to my my resource, what I exposed. Let me show you how I exposed this React resource. So I should be having here. Yeah. So this is repository geolocation resource. I don't know where it is. Yeah, tweet, right? Give me a minute. I'm just finding. Yeah, sorry. So you see here, REST API router, right? I often change my code. That's the reason. So here it's a GET request stream tweets, right? What it is doing is like it's a new way of writing the REST endpoints. This is the route, and you are giving stream text event stream. Text event stream is what the live data. I'm fetching reactive repository find with tailable cursor by, right? This is something different that this is from the earlier CRUD based repository. The tailable is what? The live stream. It will be pushing all your data immediately. Again, I'm giving you example that it's a simple tweets, which is just a find all, right? All the data which is persisted in a database, it will be pushed. Unless you refresh, you will not get the data. But this live event stream, once the persistent connection is established, you're receiving your data on the fly. So you can go through the code. It's simple Java code. You need to understand some kind of these keywords, reactive repository and a tailable cursor, all these things. Other than that, it's a very simple one. Yeah, I think I'm done with my slides. I'll be closing the slides with other two more slides. So reactive system, when you apply all these things, the tools and the designs, it's your reactive system. That's all. So external references, I'll be sharing the slide. You can get it, and this is what where you can see the Java code, the demo code what I was showing. I'll be sharing this in the chat. Okay. So if you have any questions, please we can discuss. Karishma, sorry if I over-consumed your time. If whoever want to have a discussion, please stay back. Otherwise, follow what Karishma is going to say. Thanks, Karishma.
Yeah, no issues. If anyone has questions, you can either use the chat window or you can ask him directly. Anything's fine.
Yeah, sure. I'll be waiting for your questions. Yes.
Okay. Okay, then if
Yeah,
anyone has questions, they can probably stay back. No issues. So thanks a lot for the session, Ranjith, and for everyone who joined us today. Thanks a lot for joining the session, and I really hope you enjoyed it as well. This session will be uploaded on our YouTube channel as well. So thank you. I think someone, yeah, you share the link to. Yeah, thank you. I'll probably add that to the YouTube description as well.
Yeah. Thank you. Thanks all.